Hello everyone, welcome to lecture on problems on mesh analysis. In this lecture, let us discuss two different solution methodology of mesh analysis. Let me straight away move on to the problem. Our objective is to calculate current in 5 ohm resistor using mesh analysis for the given circuit diagram. Let's move on to method 1 using loop equations. For a loop equation, step 1 is to choose loop current as well as branch current direction. How to choose loop current? You can choose any direction as per your wish. Say for example, I am choosing clockwise direction on both the loops. This is loop current 1. Similarly, clockwise direction for loop number 2. I have chosen both in clockwise direction. It is your wish. Either you can choose both clockwise, both anti-clockwise, or one clockwise, one anti-clockwise. Second thing on step number 1 is put the branch current direction. What are the branches here? There is one 10 ohm branch. Actually 10 ohm branch has only one loop current, so the branch current loop current remains same. So I take I1 here. Similarly, coming to 1 ohm branch, 1 ohm has only loop current 2. That means loop current, branch current both are same here in 1 ohm. Now coming to 5 ohm branch, there are two different loop currents are flowing in 5 ohm branch. In fact, both I1 and I2 is flowing. So we have to fix the direction here. Based on the fixed direction, we have to choose branch current. Say for example, I am fixing the direction downwards. That means I am assuming that I1 current is greater than I2 because I2 is flowing in opposite direction. I can write here I1 minus I2 is my branch current. You can also choose upward direction, that is direction with loop current 2. In that case, you have to take I2 minus I1. However, I have chosen downward direction, which is I1 minus I2. This is how to select loop current and branch current direction. So before moving to the rest of the solution of the problem, it is mandatory to understand sign convention. Sign convention for voltage source, we have two different rules. Rule number 1, if the loop current leaving positive terminal of the voltage, then consider positive sign for the voltage source. That is, if you have a voltage source like this, positive terminal at the top, negative at the bottom, then the loop current flowing from bottom to top, that means leaving positive terminal, you have to consider this voltage source with a positive sign. On the other hand, if the loop current leaving the negative terminal of the voltage, then consider negative sign for the voltage source. Say for example, I am taking the same voltage source. Now the loop current is downwards, that is leaving negative terminal of the voltage source. In this case, I have to consider negative sign for the voltage source. These are the two rules to be followed while considering sign of the voltage source. Again, to consider sign of voltage drop, it is mandatory to refer two different rules once again. Rule number 1. If the loop current and branch current flowing in the same direction on the resistor, then the voltage drop is minus I into R. Remember that I is branch current. If the resistor has upward current flow according to my diagram, that is branch current moving upwards, and the loop current also acting in the same direction with the branch current, then we have to consider minus branch current into resistor. That is a voltage drop across the resistor. Rule number 2. If the loop current and branch current flowing opposite to each other on the resistor, then the voltage drop is plus into IR. Once again, I am taking the same resistor, branch current moves upwards. Now loop current downwards acting opposite to the branch current. If this is the case, then we have to consider plus branch current into resistor. That is the voltage drop across the resistor. Then let me move on to step number 2. Let's apply KVL on loop number 1 as well as 2 and write down the equations. Let me take down the original circuit. Now apply KVL on loop number 1. This is loop number 1. Now you take any one of the point, complete the loop at the same point. I start from this place. So moving upward, I am witnessing voltage source. In order to consider sign of the voltage source, I have to check with the loop current direction. The loop current leaves the positive voltage source. So I have to take plus 100. Witness next element on this loop, that is 10 ohm resistor. Here, as per KVL, I have to find out voltage drop across this 10 ohm resistor. For that, I have to consider loop current and branch current direction. So both are flowing in the same direction. So I have to choose minus branch current multiplied by resistor 10 ohm. Then moving on to next element, I have 5 ohm resistor here. Then look at both branch as well as loop current in order to find out the sign of the voltage drop across this 5 ohm. So both are acting in the same direction. So once again minus 5. The branch current is I1 minus I2. So there are no other element, equate the same to 0 as per KVL. So this is your loop 1 equation. Likewise, you can also write down loop 2 equation. Now this time you take this loop, apply KVL and write down the equation. So start from any one of the point on this loop and complete at the same point. So I will start from this point. Okay, I am moving this direction, witnessing 5 ohm resistor here. So I have to find out voltage drop across this 5 ohm. In order to find out the sign, consider both loop current as well as branch current. Here branch current downwards, loop current upwards, acting in the opposite direction. So I have to consider positive sign for the voltage drop. So 5 times of I1 minus I2. Then the next element is 1 ohm resistor. So where I have both branch current and loop current acting in the same direction. That means 1 times of I2 with the minus sign. Why minus sign? Both branch and loop current acting in the same direction. No other element, equate the same to 0. So these are the two loop equation I can easily find out. So hereafter, rearrange this equation, solve this equation, find out loop currents I1 as well as I2, so that it is easy to find out current flow in 5 ohm resistor. This is what the equation we get it in loop number 1, and this is from loop number 2. Now rearrange this equation such that 15I1 minus 5I2 is equal to 100, as well as 5I1 minus 6I2 is equal to 0. Then solving this equation, we get I1 with the value of 9.32 amps, I2 with the value of 7.69 amps, and finally in step 3 you can calculate current in 5 ohm resistor. which is designated as I1 minus I2. So substitute the values for I1 as well as I2. Current flow in 5 ohm is obtained as 1.63 amps. Now let us discuss method number 2, which is inspection method or matrix method. The problem statement remains same. Calculate current in 5 ohm resistor using mesh analysis, and we will take the same circuit. Step number 1 is to find out number of loops and choose loop current direction. So as per the circuit, you can observe that there are two number of loops, and we have to choose the loop current directions here, which is almost similar to the one we discussed in the previous problem. But here you no need to choose branch current direction, whereas in the previous case we use both loop current as well as branch current direction to find out the solution. But here loop current alone enough. Then step 2, formulate network equation. Network equation is very simple. It obeys Ohm's law. V is equal to IR. That is what I have written here as V is equal to RI, where V is voltage vector which has a dimension of n cross 1, R is a resistance matrix which has a dimension of n cross n, and I is current vector which has a dimension of n cross 1. What about this n value which we identified earlier is 2. So we can expand this network equation as per our requirement. There are two loops, so V1, V2, and R11, R12, R21, R22 are the elements of R matrix, which constitutes 2 cross 2 elements, and I1, I2 are the two elements available in 2 cross 1 vector of current. So what is V1? V1 is total voltage in loop number 1. Similarly, V2 total voltage in loop number 2. And moving on to resistance matrix, R11 is total resistance on loop number 1. Coming to another diagonal element, R22, total resistance on loop number 2. Moving on to off diagonal elements, that is R122 and R221, both are same, which represents the common resistance between loop number 1 and 2. We have to find out I1 as well as I2 as like previous problem. For that we need these values, that is V1, V2 and elements in R matrix. Again here we have to use some sign convention. For a voltage, whatever the sign convention we used, same. But for resistance, we have to understand what is a sign convention. Before moving to the rest of the problem, it is mandatory to understand sign convention for the resistance in the matrix. To consider the sign of resistance, we have to follow two different rules. Rule number 1. If both loop currents flowing in the same direction on the resistor, then the resistance be considered with positive sign. Say for example, I have resistor R, loop current 1 and loop current 2 acting on the same direction, so I may consider plus R here. Even if the loop current acting in the same direction but downward, you may consider it as positive sign. Then rule number 2. If both loop currents are flowing opposite to each other in the resistor, then we have to consider negative sign for the resistance. That is, loop current 1 acting upward direction and loop current 2 acting in downward direction, hence negative sign for the resistor. So this way we have to consider the sign of the resistance on the matrix. With this understanding, let's proceed to the problem. Let us take down the same circuit. Now I'll tell you how to choose loop current, which already been discussed. You can choose your own direction. I am choosing clockwise. Similarly, second loop I am choosing clockwise. As I mentioned earlier, no need to choose branch current here for this category. We are supposed to find out voltage vector V here. Let me go back to the previous slide so that we can able to understand what is V, what is R. So here is the equation we have to formulate. V1, V2 representing voltage vector and R elements representing resistance matrix. Now let me calculate voltage vector V1 and V2. How to calculate V1? V1 is total voltage on loop number 1. I have only one voltage source here, so I have to consider 100. Remember, we have to stick with sign convention. So consider loop current. Current is leaving positive of the 100 volt source. We have to take plus 100. The second loop doesn't have any voltage source. We make it out 0. So my voltage vector is 100, 0. Similarly, you calculate R. What is R11? Total resistance on loop number 1. I have one 10 ohm resistor and one 5 ohm resistor. So sum of these two is R1, that is 10 plus 5. Similarly, considering second loop, I have two resistors, namely 5 ohm resistor and 1 ohm resistor. So take down 5 plus 1 for R22. Then we concluded diagonal elements. We are supposed to calculate off diagonal elements. The off diagonal elements are R122, R221, which represents the common resistance between loop number 1 and 2. The common resistance between loop number 1 and 2 is 5 ohm resistor, this one. Okay, so let me take down 5 here. Moreover, we have to find out the sign of this 5 ohm. Let me put 5. Both off diagonal elements are same, but the sign of this 5. For that, you have to consider loop current direction. I1 is downward, I2 is upward. Acting opposite to each other, you take it as minus sign. That's it. Once we concluded V vector and R matrix, we can go for mathematical manipulation to find out loop current I1 as well as I2. Let me move to voltage vector and resistance matrix. That is what we have calculated in the previous slide. Then formulate network equation and solve it. How to formulate network equation? V is equal to Ri. So I have formulated network equation, and for the solution of this problem, we have to apply Cramer's rule such that we can find out I1 as well as I2. How to calculate I1? Del 1 by del, where del 1 is determinant of R matrix with the first row has been replaced by voltage vector, that is 100 and 0. Then coming to del, the determinant of resistance matrix, and the determinant of numerator is 600 and the denominator is 65. Finally, I1 value 9.2. Similarly, go for I2. I2 is del 2 by del, where del is same as the previous case, determinant of R matrix. Then del 2, replace second row with the voltage vector and find out the determinant of this one. You may calculate and verify this answer, 7.69. So these are the two answers we got earlier in a previous method. And finally, current in 5 ohm resistor is I1 minus I2, which is 1.63 amps. I hope you understand basic methodology behind mesh analysis. I have demonstrated in two different methods. For more update, subscribe my channel.